Hello students, you are here with Miss Ledbetter and we are ready to do some math. Today we will be discussing function notation. We've been discussing in class the various types of functions that we will see throughout the year. So our objective for today is to understand the formal notation of evaluating a function at specific points algebraically. So our end result is an ordered pair or a location on the graph. And you should be recording these notes in your interactive notebook on page 5. So here we go. First of all, let's discuss this notation f of x. Remember, that's just simply another way to say y. So we are defining this equation as a function using a variable x. So now to evaluate, we will set a specific value for x, and our end result will be equal to, after evaluating the equation, will give us the corresponding y coordinate for our ordered pair. So we are going to begin by defining our function f of x to be x squared minus 6x plus 8. And we are going to evaluate this function f when the value of x is 0. Sorry, wrong color. Okay, so notice the only thing that changed from our original f of x notation is that x has now been replaced with 0. So therefore, that communicates that everywhere we see an x in our equation will be replaced by 0. So then if we replace every x with 0, our equation now becomes 0 squared minus 6 times 0 plus 8. And then we can evaluate this function by just simplifying and multiplying them together. So we know 0 squared equals 0, and a negative 6 times 0 is also 0, plus 8, then adding 0 plus 0 plus 8 equals 8. So therefore the value of the function f when x is 0 is 8. Or in other words, when x equals 0, its corresponding y value is 8, therefore defining that point at 0, 8. Okay, let's try another one. What if we changed the value of x, so keeping the same operation, the same procedure, only now evaluating at a different value for x? Let's say now that we are going to evaluate this function when f equals 3. So then again, same thing. Everywhere we see an x is now going to be replaced with the value at 3. So then our equation now becomes 3 squared minus 6 times 3 plus 8. And then we simply evaluate that function. So the value of the function when x equals 3, we know 3 squared is 9. Negative 6 times 3 is a negative 18 plus 8. And 9 minus 18 plus 8 equals a negative 1. So therefore the value of the function when x equals 3 is negative 1, or in other words, when x is 3, its corresponding y is at negative 1, defining that point at 3, negative 1. Now let's try another function. Let's define a function g of x to be x cubed minus 7. And again, we'll follow the same procedure. We're going to evaluate this function g when the value of x is negative 2. So therefore, same thing. This is telling us that the x has been replaced with our negative 2. So everywhere we see an x, we will replace that x with our negative 2. So therefore, we'll now have negative 2 raised to the third power, or cubed, minus 7. And evaluating that, I know that negative 2 to the third power is negative 2 times negative 2 times negative 2. 2 times 2 is 4. 4 times 2 is 8. And then a negative times another negative is going to end up with a negative 8. And then minus 7. Negative 8 minus 7, they're both negative, so add them equals a negative 15. So the value of this function when x is at negative 2 is negative 15. Or in other words, when x is negative 2, the y-coordinate is a negative 15. Okay? One more example with this. Again, following the same process, same procedure, only now we're evaluating at a different value for x using the same function. Now let's evaluate when the value of x is 2. So everywhere we see an x, we are now going to replace that with 2. So now we would get 2 to the third power minus 7. So a positive 2 to the third power, we would have 2 to the third is just simply 8 minus 7 equals 1, positive 1. So then therefore the value of our function when x is 2 is 1. Or when x is positive 2, the value for y is a positive 1. Now, it is also possible that we can evaluate a function graphically without even knowing the definition or the equation of the function itself, just looking at the graph. So same as we did before, let's evaluate this function f when x equals 0. So again, the x is 0 because we have replaced f of x with our f of 0, so x equals 0. So to do this, we simply find on the graph where the value of x is at 0 and where is that function when x is 0. So therefore the value of f as 0 is 8. Therefore defining that point 0, 8. Okay? Or again, if we wanted to evaluate at another point, let's say f of 3. So then this is communicating that our x equals 3. So again, same thing. Let's look on the graph, find the value whenever x is at 3. Where is this graph? And it is right there at negative 1. So therefore defining that point at 3, negative 1. So the value of the function when x equals 3 is negative 1. Again, let's look at another function graphically. Here is g of x, and we are going to evaluate our g of x. In the same locations we had originally with g, let's look at the value at g of negative 2. So therefore communicating when x equals negative 2. So then go to the graph, look at the graph and locate where is x equal negative 2 and what is the value of that function. Right there, it is at negative 2. Therefore, defining that point at negative 2, negative 2. So when x is negative 2, y in this case is also negative 2. What if we looked at a positive 2? So again, saying that x equals positive 2. So now let's go look at the graph. Find on the graph where x is positive 2. And where is the graph now located? At 0. Therefore, defining that point at 2, 0. So the value of the function g when x is 2 is 0.